Hi, my name is Hassan. I'm on topic of my PhD research is exploring deep architecture and visual cues for intrinsic image estimation. Intrinsic image estimation is an inverse operative process to get internal characteristics such as shape, reflectance, shading, and illumination from single image. In our recent work, we've shown that how intrinsic image estimation can be used to improve the performance of OCR application. Initially, we did extensive literature overview of currently available dataset and listed pros and cons of each of these datasets. We have shown that currently available datasets are either too small to be used for convolution neural networks or either photometrically unrealistic. Uh, to solve this problem, we develop a color-based data augmentation technique that extends the training data by increasing the variability of chromaticity while preserving the reflectance geometry. We've shown that our proposed technique performs really well and improves the performance on Synthel image dataset. Secondly, we developed a completely synthetic dataset of 25,000 images called Surreal Intrinsic dataset. This dataset uses the ShapeNet object in multiple sided room. For this dataset, we use multiple light sources and with multiple camera position. This dataset has a lot of variability of the reflectance and the shading. With this dataset, we also introduce an inception-based unit architecture with physical intrinsic laws to predict the reflectance and shading in parallel. The proposed architecture performed really well on the surreal intrinsic dataset as well as other realistic images as well. Our current research work is focused on another intrinsic image task to get the light properties from single light source and use it for the real lighting task. For this task, we extended the original Surreal intrinsic dataset by introducing multiple ShapeNet objects in under the color light source to have more strong shading and shadows effect. We use an exception based architecture to predict the pan tilt and the color of the light source of the light source in a single image from a single image. We also build a procedure to get these light properties from a multiple illumination in the wild dataset. In collaboration with the Stony Brook University, we built a Doc 3D shade dataset to improve the performance for OCR applications. The OCR performance is affected by the shape of the paper and the illumination condition. This dataset combines the diverse realistic illumination scenarios with natural paper textures. The dataset the dataset capture physically accurate and realistic shading under complex illumination condition, which is impossible to obtain using rendering engine. This dataset use multiple types of material to have more diversity of the reflectance. With this dataset, we also introduce an architecture to estimate the shading material and texture in a self-supervised manner. The first architecture take the color image and predict the white balance image. The second architecture take the white balance image and the texture map as a weak signal to predict the material texture and shading from the single image. The future work is to extend the synthetic dataset for the real lighting task and use the new architecture to improve the performance of the real lighting. My personal goals are to complete the PhD and find a new